consumption.
ನೀವು ನೋಡ್ಕೊಡಿ ನಿಮ್ ರಿಸಲ್ಟ್ ನೀವೇ ಡಿಕ್ಲೇರ್ ಮಾಡಿ.
Hello.
ನಾವೇನ್ ಡಿಕ್ಲೇರ್ ಮಾಡೋದಿಲ್ಲ.
Yes sir, mute sir. Joel.
Am I audible?
You're audible sir.
Yes sir, you are audible sir.
Mute that another assessment is. Just mute.
Okay.
Muted.
Yes sir, muted sir.
Okay. You can continue sir.
Okay. The myths or misconception related to irradiation and the actual facts. Actually, this is very important with respect to irradiation because there are so much of misconceptions regarding radiation in the public domain and other societal aspects and future aspects or future developments. So these few slides I will go a little faster. So necessity of food preservation is prevention of spoilage and decomposition, extension of shelf life. These have been very well dealt by the earlier speakers in detail. Ensuring food value, health, prevention of wastage, and obviously economic benefits. So in this prevention of spoilage is microbial growth because that rots and ferment, dormic enzymic activity that make changes in color, texture, etc. Chemical reactions, oxidation, causing rancidity, browning, and all that. So ensuring food value is important because everybody is now aware of food values and all that. Even the youngsters are aware. And enormous awareness has been created in the society also. So availability should be available. Actually, this availability comes under food security, not safety. Then transportation over long distances without spoiling, because transportation is very essential. Even this Swiggy, Zomato, and other, they are available in long distances also, without spoilage, and obviously, accordingly, the trade benefits. Convenience, I think Professor Anand was telling about this convenience. Now, husband and wife both are working, they need to, they cannot go for frequent shopping and other, they have to save time and other. Prevention of food poisoning, so at the same time maintaining nutritional values. Wastage prevention, yes, wastage prevention is very well important in if you take it environmental consequences as well as for economic aspects also. So market stability. Value addition means there are, due to this preservation, there are some flavors are also added which gives a good appeal to the consumers. Commonly used techniques actually which you have seen also, everything. Controlling the ambient temperature, reducing the water activity in the food sample, use of preservatives, modifying the ambient packaging or surroundings, fermentation techniques, irradiation technique that we are going to deal, use of pulse electric field, high pressure techniques, and fumigation. General techniques, actually temperature control, refrigeration, what we do it in our home. This also dealt, I will go fast. 0 to 8 degree, freezing is below 18 degree if you want to preserve for long term, and blanching before freezing if you do heat treatment, means before freezing heat treatment actually, or before drying and other, that's called blanching to inactivate the enzymes. Water reduction, humidity plays a very important role actually in spoiling. So drying, sun drying, air drying, freeze drying, spray drying, drum drying, and all that actually, all these inhibit spoiling. Salting and sugaring, yesterday the lecturer very in detail he has explained actually, adding salt and adding sugar. You can, since I am sharing my things, everything is there in simplified form, people can use it. Chemical preservatives, actually acid, the lower pH, vinegar, citric acid, lactic acid, and other. Benzoates, sorbates, sulfites, nitrates, antioxidants, prevent oxidation. As I already mentioned actually, oxidation gives rancidity and other, discoloration and other. So preserving, preventing oxidation. And then modified atmospheric packaging and other. Yesterday also the speaker nicely explained about this packaging with nitrogenous packing, CO2 packing, vacuum packing, and other actually. Fermentation also helps. Fermentation, this pickles it is added, and then wine it is added actually. Then smoking, exposing the food to smoking from burning wood also. These also explained actually. This contains antimicrobial compounds, and it dries the surface. Then next comes this vascularization, are called high pressure processing. It's subjecting to high hydrostatic pressure to inactivate the microorganisms and enzymes. Next comes pulse electric field, PEF. Short bursts of high voltage electricity is applied to the food to disrupt all the cell membranes of microorganisms and making them inactivate. And next comes our subject, radiation, exposing to ionization. This we will going to deal in detail. Exposing to ionizing radiation. First I will tell what is ionizing, non-ionizing, and other some basics I'll tell. So gamma rays, electron beams, X-rays are used for irradiating to kill microorganisms, insects, parasites, and it extends shelf life, improves food safety. Main thing is this will be, I will be repeating many times, it does not, this irradiation does not make food radioactive. Irradiation fundamentals. Irradiation is a food preservation technique. Similar to other techniques, it's a food preservation technique. It uses ionizing radiation to kill insects, molds, bacteria, and other microorganisms in food. It also inhibits sprouting and delays ripening. Similar to pasteurization of milk, it's called cold pasteurization, but used for a wider range of foods. Gamma rays, electron beams, and X-rays are used again. The process and mechanism will just see in brief, then we'll go detail. Actually, I told you 3 methods: gamma rays irradiation, electron beam irradiation, and X-ray radiation. In this, X-rays and gamma rays, they belong to electromagnetic radiation. Electron beams are particle radiation, means particles. Gamma rays are from standard sources, very active high sources, kilocuries and megacuries. This is basically an irradiator facility. The source is housed in a container, shielded container with shield opening and all that. Basically, 2 types of sources are used according to the need: cobalt 60 or cesium 137. If somebody wants to go for higher energy, then cobalt 60. Or lower energy but longer half-life, longer means you have to anyhow you have to change after 2 years or 3 years, because the source activity gets decayed actually. Because all these radioactive sources, they have a half-life. Means half-life is okay, but they are getting decayed, disintegrated. Cobalt 60 is for high energy applications, and cesium for low energy, but if they want to have a longer duration of operation. Electron beams are from accelerators, particle accelerators. This will be dealt in detail actually. X-rays also from similar to electron beam accelerators only, but there will be an additional arrangement to produce X-rays from the electron beams using LINACs, means linear accelerators. Mechanism is radiation disrupts the DNA of microorganisms and insects. So it either kills them or prevents them from reproducing, hence foliage is arrested. It interferes with ripening and sprouting. See this purpose of irradiation in my things, purpose of disinfestation, self-life extension, stops germination, stops sprouting, improves technical properties, that means flavor, texture, etc. Delay ripening and decontamination. Decontamination especially for cereals, pulses and all that actually, where you remove the unwanted microorganisms and say insects, flies, etc. Again, the same thing, agricultural applications in pictorial form. You can see everything same. Disinfestation, sprout, this is for cereals, this is for potato, onion, ginger, garlic. This quarantining for fruits, disinfestation for pulse and dry fruits, pathogen reduction for spices, and for meat, self-life extension. Now we'll go to the food irradiation history. It's a long history. I just started from the discovery of X-rays actually. In 1895, then first patent for ionizing radiation for preserving food It was done in 1933, and first commercial application for food irradiation was in 1953, and FDA approval for using irradiation to sterilize food products was in 1958. FDA approval for irradiation to control insects in wheat and wheat flour was in 1963, and products standardization, that is UNO standard guidelines and that was done in 1980. FDA approval for control of microorganism in pork products. 1990s, European Union approves all these things. 1990, irradiation approved for pathogen control in meat and poultry. It was done in 2000, also approved for shell of eggs actually. And 2003, the great thing happened. WHO and IAEA, they endorse the safety and efficacy of food irradiation. Our Atomic Energy Regulatory Board and FASI and other, they have also consequently approved. Irradiation techniques are not unique. That means they are multiple. That means again we have seen the same thing: gamma radiation, electron beam radiation, and X-ray radiation. We'll see in details. Gamma radiation, as I told you, two sources are used: cobalt-60 and cesium. Somewhere very rarely iridium-192 also used, but generally cobalt-60. They have a wider beam. You get wider beam in cobalt-60 as well as cesium-137. And cobalt-60 is a gamma emitter. First, it's a beta emitter, and it emits two gammas. Of actually, the energies are expressed in million electron volts. That I will explain you later. Just remember now, MeV is the energy for these gamma rays and other subatomic particles. So cobalt-60 emits two energies. One is 1117 MeV and 1332 MeV, in addition to a beta. In fact, two betas are there, either one can happen. Another is cesium-130, and cobalt-60 is having a half-life of 5.3 years, and cesium-137 is a lower energy, 662 keV, but having a half-life of 30.5 years. But 662 keV is also a powerful gamma ray, nevertheless. The mechanism again penetrate deeply into the food, disrupting DNA of the microorganisms and insects. Advantages: highly effective, good penetration, because since the gamma ray penetration is very high. Widely used, well-established technologies. In fact, most of the food irradiators in this world are gamma irradiation and well-established technology. In fact, I remember about 25 food irradiating facilities are there in India. About maybe this may be 2023, maybe additional. In Tamil Nadu, I hope there are 8 have been opened, but how many are operating, I do not know much, because I just 1 year back only I came from Calcutta. I was there working in accelerator center in Kolkata, and I was looking after 3 facilities. In fact, inspecting a food irradiation facility also there in Kolkata. So disadvantages is require heavily shielded facilities for safety, public perception concerns. So this is a very high level radioactive source is used, and the security things are not very tight. You cannot provide for these type of facilities, and that actually now with terrorism and other problems, it is a concern only, because if somebody takes away the source, steals the source, and then use it for, say, malign activities and other for bad purposes, terrorism purposes and other, it is really very great problem. In fact, I was an emergency response coordinator training the military people and police and other on this dirty bomb and other radioactive and nuclear emergency response also. So I know about this public perception concerns and other, but now we are involved in clearing the myths from the public. Now I'll go to the electron beam irradiation. Electron, this is from electron accelerator. Accelerators means they are accelerating the atomic particles. Means increasing the energy. Acceleration of a vehicle means you are increasing the speed, basically. So here increasing the velocity, thereby you are increasing the kinetic energy of the particle. So it's called accelerators, particle accelerators. And then there are different type of accelerators. Linear accelerators are there, and cyclic accelerators called cyclotrons and other. Electron accelerators, they produce a beam of very high energy electrons. So in terms of MeV, mechanism is electrons directly interact with the DNA, the same, almost the same. But advantages. Here advantages, beam can be switched on and off instantly. Whereas in case of gamma irradiation, you need to have a shutter. The shutter closes slowly, though it's not very slowly and all that. Here, but till the radioactivity remains within the shutter, though it is well shielded and all that. But here,
Sir?
the moment you switch off the machine, hello?
Sir, excuse me, sir. Sir, can you please hide that tab in the screen, sir? The small, the bottom.
Oh, sorry. Thank you. Okay now?
It's okay, sir.
Okay, sorry. My bandwidth is okay?
Yes,
That
yes,
means
yes.
my audio and
Very
video,
clear,
is it okay, smoothly going?
Yes, yes, smoothly going, sir.
Okay, sorry, thank you. I should have done it earlier.
No,
So
sir, not.
advantage here when compared to the gamma irradiation is you can switch on and off. It's a very great advantage. You should try to visualize. In gamma irradiation, the source is intact. It's a kilocurie source. Even a Curie source, if you put it in a pocket, within a few days, you will die. Okay, within hours, few hours, you will die. I am talking about kilocurie and megacurie source and other. If it goes in the hands of miscreants, actually it will create an hava. But whereas that's why public perception concern is there. But nevertheless, now enormous security interlock arrangements have been done actually in the modern machines and other modern facilities. Electron beam irradiation and X-ray radiation, actually you have both, they have the advantages. Beam can be switched on and off. The moment you switch off, the radiation ceases actually. The radiation is not in the electrons. When interaction, only the radiation produced, and that deposits energy. This uses higher doses for faster processing, good control, for penetration depth, considered more consumer friendly. But great disadvantage is there. But it is for specific applications. It's for surface treatment and low depth treatment and other. Lower penetration than gamma rays. It can penetrate up to 8 centimeter only. And it is obviously it is very expensive when compared to gamma radiation facilities. Now we'll go to the X-ray. X-ray, I told you, it's similar to the electron beam irradiation only, where there is an additional arrangement has been given. I will show you in pictorially where the electron beam interacts with the tantalum or tungsten target and produces X-rays, generated by bombarding a metal target with usually tungsten or tantalum with high energy electrons. And gamma rays, they are indirectly ionizing radiations. Like gamma rays penetrate deeply into the food and disrupt. X-ray is also radiation, but X-ray is similar to gamma rays. It produces indirect ionization. Advantages can be switched off and on, similar to electron beam irradiation. Potentially better public acceptance than X-ray machines are there everywhere. Even for our diagnostic purpose, we use X-ray. It is X-ray radiator. People, gamma means they are getting afraid, and X-ray means, of course, X-ray say gamma rays are more energetic. Definitely, no doubt about it. There are high energy X-rays are also there. What we use for dental X-rays is very low level actually. What we use for our chest X-rays and other X-rays, few kVs only. Even for dental X-rays, less than that actually. Disadvantages, relatively expensive compared to gamma irradiation and E-beam. Lower efficiency. This is another problem with X-ray radiation. It means you need cooling, you need higher power, so you need higher electricity and other energy conversion are energy, what you call energy economics is not that better than gamma irradiation. Now, factors affecting food irradiation treatment. So for all type of food, same type of things are there. Type of food what you are using, then you have to give a different type of irradiation. Radiation dose, based on the type of food, you have to choose the radiation dose. Those data and all that I'll give you. Then the treatment plan as well as treatment plant design. That means the facility design. So design is based on regulatory compliance. Regulatory authorities are telling enough safety guides are there. Atomic Energy Regulatory Board is the regulatory board for India. In fact, one of the guides I was a co-author of editorial. I was in the editorial board. And the exposure time and temperature, because this radiation, say for example, if you take gamma irradiator, gamma rays actually due to disintegration, like cesium-137. Cesium-137, it decays into barium-137. During the decay, what happens? Beta rays and gamma rays are emitted. During the decay process, enormous amount of heat is also produced, and that need to be cooled also. And exposure time, because the radiation dose, overall dose absorbed depends on the exposure time also. Some products require lesser exposure time, some are more. Some will have a higher exposure rate but lower exposure time and all. This is because of the texture of the food sample getting irradiated. Now I am keep on telling radiation dose. What is radiation dose? You should know. So first of all, I do not know how many people are aware. In the students, I heard mechanical engineering students are there, pharmaceutical students are there, some biological students are there, and all that. Am I correct? I do not know. But how many people are knowing about the difference between radioactivity and radiation dose? Can anyone tell? Okay, let me explain. See, some unstable elements are the isotopes of the elements. Like see, you have hydrogen is there. Hydrogen is having isotopes, deuterium and tritium. Tritium is a radioisotope. There are cobalt, normal cobalt is there, cobalt 60 is there, cobalt 59 is there, cobalt 60. Cobalt 59 is stable, whereas cobalt 60 is an unstable. These unstable elements, what they do is, they emit spontaneous radiation and thereby getting converted to cobalt becomes nickel. So that way they disintegrate or decompose. The number of disintegration taking place, is what you call radioactivity. See, the unit of radioactivity is becquerel. That means how many disintegrations per second are taking place is called radioactivity. But these radiations, they fall on human being or on material, and they deposit energy. The amount of energy deposited in terms of joules per kilogram is called radiation dose. There are so gray, it's called gray, GY, capital G, small y. One gray, if you just assume if 1 joule of energy is deposited, because they are all energetic particles, they deposit energy in the cells, in the body, or in the cells of microorganisms. If 1 joule of energy is deposited 1 kilogram of the substance, then it is called 1 gray of radiation dose. But 1 joule is a very, very high unit when respect to actually in common mechanical sense, 1 joule is a small unit, you know very well. 1 Newton force pushing something to 1 meter, then you will get work done is 1 joule and other something. But in terms of nuclear and atomic physics, or that level, this joule is very high in it. Just remember. So 1 gray is equal to, so how then 1 joule is a very means. So it's not deposited in kilograms. You just remember all these things are deposited in DNA level. So you can imagine the weight of it. According to Codex, that is UNO general standard, the maximum dose delivered to food should not exceed 10 kilogram. This is AERB standard also. The AERB, Atomic Energy Regulatory Board, is responsible for regulating the source of radiation and dose of radiation that are used for irradiating the food. The use of appropriate radiation doses is most critical factor, because basically the radiation only, the dose only kills the microorganisms. Just I'll go faster. You may be knowing about radiation, ionizing radiation and non-ionizing radiation. See the microwaves in your mobile, infrared rays, radio waves used in cell phones and other ways, also microwave ovens also, they are non-ionizing radiation. They don't ionize. What do you mean by ionization? Hello? Hello? Am I audible?
Oh, yes, sir, you are audible, sir.
Okay, sorry, some disturbance was there. Actually, I do not know. Okay.
Sir, sir, just mute.
Okay. I'll continue. So these microwaves are radio waves, these micro radio waves in between cell phones and then your radio broadcasting, TV broadcasting, what you are using, even for heating purpose, you are using infrared rays for pain killing and all that, ultraviolet rays for skin and all that. These are all non-ionizing radiation. They are also radiation. What is the difference? An ionizing radiation, actually, when they interact with the atom, if they knock out the electrons, then it is called ionizing radiation. If electrons are knocked out, the electrons are only shifted between one shell to another shell, then it's non-ionizing. So that is not, because that is not really giving that much harmful. They are also harmful in that sense. These non-ionizing radiations, they produce enormous heat. See, you take a microwave oven. Microwave oven produces what? Actually, it produces enormous of heat. But ionizing radiation, they produces ions. These ions, if these ions are happening in terms of cell, the elements of cell, then the cell death, cell mutation happens. So they are much more harmful, ionizing radiations. This side all high frequency but low wavelength. Non-ionizing higher wavelength but low frequencies. Okay, these are all called electromagnetic radiation. Gamma rays comes into the electromagnetic radiation. Your X-rays, electromagnetic radiation, and other. Gamma rays and X-rays are closer. Higher energy gamma X-rays and low energy gamma rays are very close. Actually, they're not much, very thinly separated. Only the difference is origin. X-rays are atomic origin, whereas gamma rays are nuclear origin. Now, actually, this radiation, alpha, beta, gamma, alpha particular radiation, beta, also when nuclear interaction is taking place, alpha particles are emitted, and then beta particle is nothing but electrons in the form of beta particle emitted from the nucleus. Nucleus, there is no neutrons, but these protons and neutrons, they decay and then to give this beta particle. There are two type of beta particles, beta positive and beta negative. Beta negative, they are called electrons, and beta positive, they are called positrons. Alpha particles, actually, they penetrating power, it cannot even penetrate a paper. Beta particle can penetrate paper, but with low Z metallic objects, it will be stopped. Gamma rays can be stopped by heavy metals like lead. Neutrons cannot be stopped by these type of shielding, but it will be stopped by a hydrogenous material like water or concrete. Concrete also contains chemically bound water. That's why concretes are used. Even these irradiation facilities we are talking now, all these things are made up of concrete. They stops neutrons, because during very high energy, like particle accelerator facilities and all that, neutrons are also produced. high energy Linacs also neutrons are produced. These neutrons has to be stopped. So you need actually concrete which is used for structural strength, mechanical strength, as well as for stopping these radiations also. They are reinforced concrete. They have iron, actually iron inside the concrete that stops gamma also. Achha, wherever these figures are there, which I have taken, I have given the reference. Okay. Okay. Then see, I was talking about this, telling you repeatedly this radiations by irradiating, you are not making them radioactive. That concept you have to take it. Especially the range what we are using for food irradiation, that never makes the sample radioactive. See, for that you have to understand this one. Exposure, how this happens. If the source is outside, a person is standing, the radioactive source is intact. The gamma rays, the beta particles cannot travel this much distance. Only alpha particles also range in the air is very small. So mostly gamma rays, X-rays, they cannot, X-rays are not from, X-ray generators are there, gamma rays from the source. And they will deposit only energy. They don't deposit any radioactive material in the body. So once you are moved out of the site, I'll tell you time distance shielding and other. So then you are safe, completely safe. But if somehow the radioactive source has gone inside, how it can go inside? Just you assume you are in the middle of a radioactive cloud or an airborne contamination area where it is filled with radioactive vapors and all that. If you don't use personal protective equipments, then if you do inhalation, it will go into your lungs and body. So if you are not using the personal protective equipments like gloves, coveralls and all that, and then your hand got contaminated with some radiation leakage and you are not washed and you have taken food, it will ingested, it will go into your body. And for therapy purpose and diagnostic purpose, radioactive isotopes are injected. That's called injection. Skin absorption in nuclear reactors and all that. Actually, in most of the nuclear reactors, I worked in nuclear reactor also. Nuclear reactors, actually, most of the Indian 17 nuclear reactors are pressurized heavy water reactors. Heavy waters. These heavy waters are all subjected to neutron. They become tritiated water. If there is a leakage in the line, the working person will get completely bathed in with tritiated water. So through the skin, the tritiated water, which is radioactive, tritium is radioactive. Tritium is nothing but a H3, the isotope of hydrogen. So that way, this is the internal exposure. Internal exposure, what is the disadvantage? Here in external exposure, you move out of the source, you are safe. Here, even you move, you don't have to, because it is there already in your body. Only it is having a half-life. There are two types of half. In fact, physical half-life, biological half-life. So physical half-life is normal half-life what we are talking about. I told you cobalt 60 is 5.3 years and all that. So that many half-life in one half-life it will become half, then almost 8-10 half-lives it becomes zero. But this whatever you are using for like injection, I told you for radio, they are all in few minutes only. Few minutes at the most few hours. So they will decay out of the body. In fact, other than the physical half-life, there is a half-life called biological half-life. That means your body is having excreting things. So the biological half-life is based on that your excretion capabilities. That means your excretion values, rate. And the effective half-life is a combination of these things. So it's not like that if it is few years also, it will not be few years. Because body, the foreign body itself will get things excreted out. So this has shown what is radioactive things becoming radioactive and irradiation is there. To understand these things, actually, I have explained this slide. Say for external hazard, this fastly will go time distance shielding. So the lesser the time you are exposed, the lesser the dose. The higher the distance, the lower the dose. That means with the distance, it follows inverse square law. Shielding, if you put shielding material, I told you gamma rays are shielded by metals like lead and all that, actually lead. So you can stop it or you can reduce it. For internal hazards, what you have to do? You have to follow contamination control. You have to barricade the thing. You have to should not allow people to go into that contaminated area. People should wear PPE, personal protective equipments like rubber gloves. They should wear coveralls. They should wear ventilated suits, head cover, and breathing suits, self-breathing apparatus, and all that. So now I will show you a typical. There are different type of gamma irradiated facilities are there. I will show you a very typical. There are even different types are also there, but normal. See, this is the gamma irradiated facility. I told you there are three ways of irradiating. One is gamma source irradiation, then electron beam irradiation, another is X-ray irradiation. This is a gamma irradiated facility. You see, loading is loaded. This is conveyor. It goes. In fact, many cases actually it may be in the ground level also. It may be in the basement. Basement. The advantage in basement is you need to have a lesser shielding because earth itself will give a good amount of shielding. Shielding thickness you can reduce. Shielding is generally made up of concrete, high density concrete. Okay, so it's more than around 2.5 to 3 or high density concrete. Ferrite concrete is more than 3.5 gram per cc density. So what I want to tell you is in the ground level you can have very heavy shielding, but if it is in the basement, the source is in the basement, source is housed, and within that one there is a pool and ladder type arrangements where these boxes containing these samples which is to be irradiated, that will go like a conveyor belt, it will go and then come out. Okay, radiation source. The pool and other given water cooling arrangements is given, as I told you. During irradiation, heat is produced also. This is the irradiation room. This is a radiation shield and conveyor system and all that. This is electron beam facility. Instead of radiation source, there will be an E-beam electron beam accelerator, particle accelerator. And here you have a beam line and with conical type of say slit. So conveyor on the conveyor you have these products are moving and irradiated. Process food goes control console. The previous things you see, the control console, the operator is outside the shield. Okay. Similarly here also. And this is for X-ray, same thing. This is an electron gun and then facility. These electrons are coming. This is just see, this is a very thick tantalum or tungsten which produces X-rays. And this is a conveyor where the samples are being irradiated. This is a LED screen, such type of screens you might have seen in an X-ray facility also. Typically irradiated facility, irradiator truck comes, irradiation chamber, then getting irradiated. You see a lot of pathogens, and then after irradiation, very less minimum, and it goes to the truck is again it is loaded, goes to the grocery store. Now I'll come to the food irradiation. Two different types of irradiation: direct and as well as indirect. I'll go to the next slide. I'll come back again to it. See, in the direct, it directly breaks the DNA of the sample or the cell of the sample, and which leads to cell death. And indirect, it produces, actually it interacts with the moisture or water. See, most of the organic things, they have moisture. In fact, if you take our human body, it is 70% water. So radiolysis, I will just give the reactions I will show you. And it produces free radicals. These free radicals you might have heard. Antioxidants, cancer prevention, and all that you might have heard. With the age, actually, this free radicals production in our body also very high. That's why old people like me and all that actually are more susceptible for cancer and other carcinogenic. So these free radicals are produced, and that form some are they are made to have very active components like hydrogen peroxide and other, which chemically breaks actually the DNAs and other, which causes cell death. I'll go to the previous. Direct effect, this electromagnetic radiation, X-ray or particle beams like electrons, directly strike a molecular complex, a biological material, for instance, microbials, altering and destroying its biological function. This can lead to chromosomal disorder or mutations, and some cases death also, cell death. However, direct effect is considered less important when considered to indirect effect. In high moisture foods, radiation produces free radicals through radiolysis of water. Highly reactive hydrogen and hydroxyl radicals are produced, H and OH radicals. They combine to form hydroperoxyl radicals. That means H2O2, hydrogen peroxide. They play a major role in the microbial inhibition through oxidative effect. They interfere with the biological reaction, alter molecular structure, breaking the DNA molecules and all that. So this is the reaction. H2O with the energy of that whatever your radiation, it forms H2O plus and E minus, and this H2O plus and E minus forms H plus OH and E minus aqua. This is OH is a OH radical, and this other H2O with the electron, it forms H and OH. This H is a free radical. This H plus from here and this from H along with a free electron forms H2OH and OH forms H2O2. There are other things also. You see many places this H2O, many reactions are there. This OH is a free radical, again like that. These all other reactions are taking place in the radiolysis. Main thing is OH and H, and which produces this H2O2. So this is indirectly damage, this indirectly killing the microbials or destroying. See the ranges, dose ranges for, see, if you want potatoes, onions, garlics and other, you have to use up to 0.15 gray. Meat for destruction of parasites, 0.3. Grains, flour, coffee beans and other dried fruits, 0.5 up to 0.5 kilogray, all kilogray, 10 to the power of 3. Insect disinfestation. Somebody should, as I told you earlier also, say, gray is 1 joule per kilogram. See, you know, what is the level of a cell? Cells are all in terms of microns actually. If you say DNAs are all in nano level actually. If you take it, say particles like electron, proton and other actually, they are of 10 to the power of minus 15 level. Minus 15 minus this nucleus is of 10 to the power of minus 10 and electrons of 10 to the power of minus 18 levels. So that is their size. So you cannot imagine their weight actually. So since that joules per kg, the denominator part is very, very low. So the dose is very high. Kilogray you will be able to get it. So that I can give you one small things actually. Hopefully I am having time. I used to tell my students and that I used to take training classes also sometimes, other than my research and as well as emergency coordination and other things, safety head. See why people taking X-ray or when they are undergoing gamma radiation, means for say scans or other things, they don't get any pain. Why do they don't get pain? The main reason is, see, you take just I will give a small example. If you take a screwdriver and hurt yourself, or a pencil, you take your pen and then try to hurt, and then you have to apply a lot of pressure because you know you are a mechanic. Most of the mechanical students, force per unit area. The unit area is small, then the pressure is very high. Similarly, what happens? You cannot you penetrate your thigh or your hand. You need to apply huge amount of force. But if you use a needle, like injection needle, just to push it, it goes very deep also without much pain. So there, because the surface area is small, similarly here, these things, they go and they don't interact with your main tissue level. They interact with your DNA level, 10 to the power of -9 level. That's why you don't get a pain, because the sensory nerves are all quite bigger actually. Okay, I'll come to the grains flow, coffee beans, etc. and other. You have to give 0.5 kg. This for insect disinfestation, and for fruits and vegetables for reduction of microorganism, you have to give up to 5 kg. And then for mushroom and fruits, for delay maturation, actually the fruits should not be ripened very fast, and that in that case you have to give around a level of 1.5 kg and all that. So irradiation techs, they are already, I told you, cold sterilization, effective in lengthening the shell life of fresh fruits and vegetables, green technology, nutritional stability of irradiated food. This I will come disadvantages also. I'll tell you what small disadvantages are there. Minimal loss in texture, flavor, aroma, color of the food. It does not, again I will tell you, it does not make the food radioactive. It's very, very safe. That's why in 2003, UNO has accepted it and everybody is following throughout the world. Okay. In sterilization, yes, many people have told about sterilization is much more than pasteurization. Some of your students have told 120, 121 degrees centigrade is required. And irradiation also, cold sterilization, you can do it with irradiation. You can sterilize this medical equipment like gloves, like knives, your surgical equipments, and bandages, etc. And other. One great advantage in medical sterilization with irradiation is, you know, if you do with most of the, not every, most of the sterilization, you have to, finally you have to pack it. During the course of packing, there is a possibility of contaminants entering. But here in, this is hygienically, the hygienic sterilization has to be done here also. But afterwards it is packed. After packing with irradiation, it is sterilized. Because it is vacuum packed or sealed. With the packing, you can sterilize with irradiation. Then there is no further contamination or risk of contamination during packing and all that. See, there are three modes. Basically, you irradiate and prolong the shelf life. Irradiate and kill. Irradiate and canning food. That is radioization. This is applies for low radiation, prolonging the shelf life during storage, inhibit germination, pest control, slow germination, and all that. Radicidation. This is killing. Killing means higher, up to 10 kg is required and all that. Selectively kill microorganisms like salmonella and all that. Apretization. This is used in cannings actually. Food cannings and all that they use. Now they use up to 50 kg. It's applicable for sterilization of spices, meat products, dietetic food for sick people also. So they require much more care and all that actually. Sick people require. So radioization, radicidation, apretization. Merits, anyhow, this few times I will tell you, very quickly I will tell you. Again, microbial load and enhanced food security, minimal impact on nutritional, versatile utility, reduced spoilage, reduced reliance on pest control sprays. So you can reduce the pest control sprays during the production of the agro products also. You can have. And for especially for fruits and vegetables, delay the ripening of green bananas, inhibit sprouting of potatoes, prevent greening of potatoes, soften legumes, shorten their cooking time, increase yield of juices and grapes, increase speed of drying rate of plums, for benefits for especially for fruits and vegetables. Now I come to the important and interesting part of it. Myths. There are many myths. I have quoted some 8 important myths or misconception about this irradiation techniques. So I don't read here because I'm going to handle separately. There are 8 are there. First myth or misconception is irradiated food becomes radioactive. This already I told you again. The energy levels, irradiation does not make food radioactive. The energy levels used in food irradiation are restricted. So why I am telling energy levels? Because very high energies, there is a possibility of making the sample also radioactive. Here is much lower. There is no possibility, zero possibility of making the food irradiation radioactive. And so energy levels are restricted, does not induce radioactivity in food. The process is similar to shining a light on an object. The object does not become a light source. It's simply exposed to just an object. You are with a shining and the object with a light. It does not give an energy unless it's very for a long duration or very high intensity. Simply just showing a light. That's all. Irradiated food loses significant nutritional value. Minor nutrition losses can occur during irradiation, but they are comparable or even less than during cooking or canning or freezing. Nutrition loss depends on the type of food, the dose of irradiation, and storage conditions. Irradiation preserves nutrients by preventing spoilage. So spoilage, if is less, then nutrients are also prevented. Nutrients are also maintained. Irradiated food tastes bad or has a strange structure. This is another myth. This does typically used are relatively low. The doses are typically low and does not usually cause noticeable changes. And only for some radiation resistance bacterials and other, there's some possibilities there. Otherwise, they don't do it. Any changes are often less noticeable than canning or drying methods. Some people maybe are very sensitive. They may get under that, but it is a questionable thing. It's not scientifically proven. Irradiated food is dangerous to eat. See, already I told you WHO and FDA all endorsed it, and there is no question of dangerous to eat and all that. Irradiation is used to cover up poor hygiene practice. This is another lame excuse. See, irradiation reduces the risk of foodborne illness, but it is not a substitute of good hygiene and sanitation practices. It's an additional safety. So, good hygiene during packing, during everything process and other is required. So, it's not to cover up poor hygiene practices. Only processed foods are irradiated. This is also not true. Processed foods as well as fresh fruits are also irradiated. Irradiation can be used on a wide variety of foods. Fresh fruits, vegetables, meat, poultry, seafood, spices. It extends a shelf life, prevents spoilage, reduce the risk of foodborne illness. Irradiated food is not properly labeled. Earlier it might have happened, but now strict regulatory compliances are there. Nobody can do it. They have to put Redura symbol, international recognized symbol, and statement indicating treated with radiation or irradiated. So this allows consumers to make their choices. Irradiation destroys all vitamins. This is another thing, but there is a small studies are there. A small reduction of means destroying of thiamine. In fact, thiamine is generally even we call one is boiled rice and then raw rice. To take people who are eating raw rice, actually they are deficit of thiamine because thiamine is present in the husk of the rice. During boiling or parboiling, the thiamine diffuses into the rice. That's why parboiled rice is more nutrition than raw rice. In many cases, benefits of irradiation such as preventing spoilage and reducing foodborne illness overweigh the minimal vitamin losses that may occur. They are all much very small actually. This destroys all vitamins is not true. Societal application, there are many societal applications of this irradiation. Means that generally in general, as Joel mentioned, it's a broader applications are also because Since I got the opportunity, just I'll give some broader applications in very fastly. I will tell you. Diagnosis, radiation diagnosis, radiation therapy. I will show you some slides. Therapy means radiation treatment, sterilization, palliative care. Palliative care means for terminally ill cancer patients, they need some pain reduction and all that. For that, actually, radiations are used. Then a lot of industrial applications, agricultural applications. Each and every I'll discuss. Research applications, security applications, and all that. Medical, as I told you, diagnostic imaging. You have PET and SPECT, positron emission tomographic scanning, and this I'll tell you later in detail. SPECT, single photon emission computed tomography. These two type of, actually basically they use radioisotopes are injected and then scanning is done. Bone scans, for bone scans actually they use thallium and all that. Thyroid scan they use iodine. Then radiotherapy treatment is done with even cobalt. External therapy, closed contact therapy means radioactive pins are inserted into the body and they are also treated. They are called radiotherapy. And just now I discussed about sterilization of medical equipment and palliative care. Industrial non-destructive testing. Non-destructive mechanical people, about actually these long conduit pipes, and then if there is any defects are there, and welding defects are there, and all that casting defects are there, you can use it. So they use industrial radiographers. They come with a radioactive source. They take images, and then they find out if there are any defects are there and all that. Radiation gauges are there for measuring thickness, density of liquids and various other materials also. They pass the radiation and how much of attenuation. Attenuation depends upon the thickness. Attenuation means reduction of radiation level. So with that one, they will find out that, and it is properly calibrated to know the thickness and density. Sterilization, we have seen food irradiation, cosmetic, pharmaceuticals and all. And industrial cross-linking of the polymers, Havells cables and all the cross-linked polymers, cables and all that, very strong. Nico cables are there and all that. Track of flow of materials, you can add a radioactive material, and if you have a detector, moving detector, or a detector can be moved so that you can find out whether that flow of liquid is, if it is in a very minute level, also you can find out with the help of radio tracers. Well logging for oil and gas reserve findings, generally people may be knowing. And mineral analysis, the presence of different minerals in rocks and other things and all that you can also do with radiation. Sorry, I will take this more, just take water. So in agriculture, full day radiation we have seen. Insect control, sterile insect technique. SIT uses radiation to sterilize the male insects. They can sterilize the male insects. And plant breeding for mutation in plants. Soil moisture content. This they use neutron. In fact, I have done also moisture content in soils, moisture content in concrete, experimental as well as theoretical work also I carried out. Actually, I have some publications also. Soil moisture content and do it with radiation. Tracer studies. This is again like plant, the fertilization uptake to the entire plant branches and all that you can do with radio tracers. And research, actually, since I worked in a particle accelerator facility, high energy particle accelerators, they use radiation, and that is used for basic fundamental nuclear physics research, material science research, radioisotope production for medical purposes and other purposes, industrial purposes, and chemistry, biochemical chemistry studies, reaction studies, biological effect studies. Material science means material damage studies and reactors and all that you can you are using materials which undergo a lot of stress and strain, mechanical properties changes that you can do in a small in a test manner in accelerators, particle accelerators and other using radiation. Radiocarbon dating, you might have heard of it. Carbon 14 is radioisotope is being used. And other than radiocarbon dating, it's called thermoluminescent dating. used in pottery dating, like in excavations and other, what is happening in Tamil Nadu, many places. Thermoluminescence, basically, it is when it is heated, it emits some illumination. With that illuminance, actually, they can get some data out of it, actually. That is called thermoluminescence dating, actually. In fact, this thermoluminescence dosimeters are used for recording personal exposures, means the dose received by an employee or a worker. Security, cargo scanning and all that in international borders, district borders, national borders and other things and all that. State borders and all that. Gamma, if somebody is carrying weapons and other, nowadays terrorism becoming actually a threat nowadays, the present scenario. So gamma scanning, you can do it for weapons. So they will penetrate and give the imaging of that. And neutron activation analysis, they can do the explosive detection. So this neutrons, very small neutron generator, they penetrate, they pass the neutrons, and that neutrons activate the things, and they give some characteristic gamma rays. The gamma detector, you can find out and then see the explosive chemicals are there or not. You can find out with that one. You can detect the explosives are there in a cargo and other. Border security also, again, portal monitors are installed, so that even airports, railway stations and all that, our department has employed a portal monitor to detect illicit trafficking of radioactive materials. See, this is different energies and different dose. I don't go on, I'm giving the thing. Just I will give you the, you cross linking co, you require almost 0.3 to 10 MeV energy, and you require almost 50 to 300 gray. Even diamonds can be with irradiation, you can color the diamonds, original diamonds. You require 10 MeV. 10 MeV accelerators are used even near Kalyani. There is a place actually in near Kolkata, actually, where the diamonds are colored. And few grays only. Food preservation, we have already discussed. Sterilization of medical equipments, you require up to 10 MeV only, but you require 20 to 50 kilo grade. So just very fast I'll go. This is a medical cyclotron and VCC, where regularly radioisotopes are produced, like thallium-201, iodine-123, gallium-67, indium-111, fluorine-18, and daily this fluorine-18 in the form of FDG is produced and sent to hospital for diagnosis and all that, actually, cancer diagnosis. So this is the sector where I worked. I was the safety in charge of the, actually, for such 3 facilities. This cyclotron, there are different beam lines are there for producing PET isotopes, SPECT isotopes, and material for material science studies and all that. Actually, you have different beam lines from the same cyclotron. It's basically a particle accelerator, which I discussed. Actually, you see the half-lives are very small only. This fluorine 18 is only 110 minutes. In 24 hours, it becomes zero almost. See, this F18 is processed in hot cells, and they are done through remote handling, either manually or automatically. Transport systems are there. This is within a very enclosed shielding systems and other. After production, it is transported and it is taken to the dispensing room, which are kept in clean room. You know, I think many people may be knowing about clean room concept. The number of particles are restricted. Class 3 or class 4 type of clean rooms, not more than 1,000 or 10,000 particles per cubic meter is allowed. And this is an automatic disposing units, and quality control facilities are also there. See, these are the some of the isotopes I'm showing you. In cyclotron, energetic charge particles are required to bring about nuclear reaction. Basically, you require a proton beam or a deuteron beam, or generally used, or an alpha beam is used. Target preparation, target cooling, selection of energy, all these things are important in when compared to reactor. Actually, reactor also means nuclear reactor also, these isotopes are produced. You are thinking of isotopes. See, why I am telling these things, we told gamma sources and where these things are produced. They are produced either in cyclotron. Cyclotron means is a cyclic particle accelerator. See, like copper 65 with alpha particle, A stands for alpha, just take it because that alpha symbol I could not use it in that actually. They had some, it's an old slide of me. So gallium-67 plus 2 neutrons. The energy of the alpha is about 32 MeV. And tellurium, which gives iodine 123. And this energy of the proton requirement is 14.5 MeV. So I was telling you 1 MeV is about 1.6 into 10 to the power of minus 13 joule. That means if you take it reverse, 1 joule about 6.25 into 10 to the power of 18 EV, okay, or 15 MeV. So joule is a very, very big unit, MeV. But even with this energies also, see, I will tell you, if somebody receives a dose of 6 to 10 gray, a human being, it is a fatal dose. 6 to 10 gray, not kilogram. Okay, reactor also, these radioisotopes are produced, different modes are there, N gamma, Ng means N gamma, neutron irradiation emitting gamma, neutron irradiating emitting fission particles, N proton, R products, Ng reaction, this is molybdenum is produced, and with the neutron it becomes, this is stable, this is radioactive. Molybdenum 98 to molybdenum 99. Uranium 235 is a fissile material with a neutron. It gives a fission along with this one, molybdenum 99. They are chemically separated and all that. Various these methods are the precipitation, chromatography, solvent, extraction, distillation and all. So need for automation and remote handling in a shielded box. This is a Dhruva reactor in Bhabha Atomic Research Center, BERC, Bombay, Trombay, and this is producing isotopes for all these radioactive sources. Nuclear medicine, branch of medical science which uses unsealed sources, radioisotope suitable formulation. You have pharmaceutical group, radiopharmaceuticals are there, management of various diseases. This radiopharmaceutical uses 90% they are used for diagnostic application, for therapeutic application only 10%. So the branch of medicine which uses this radiopharmaceutical is called nuclear medicine. So this I will go a little faster, means of course we have not many slides, I have another 10, 12 slides only. Highly pure, non-toxic radiochemical formulation suitable for administration to humans orally or intravenously. So either it given orally, in the case of iodine, iodine uptake is given. In the case of other isotopes, for example, FDG and other, intravenously it is given. For organ investigations, it is in vitro or by studying localization, uptake, excretion, and distribution. Certain cases are bring about a therapeutic effect. So, so the therapeutic effect is determined based on all these things: localization, uptake, excretion, and all that. So commonly things is iodine 131, technetium 99, a metastate, then fluorine 18, and technetium 99 are different forms. Actually, you cannot just directly use the radioisotopes. You have to use in iodine in the form of sodium iodide, technetium in the form of sulfur colloid, fluorine in the form of a glucose called FDG, fluorodeoxyglucose. Okay, similarly technetium also. See, this is your imaging study. See, it is getting injected here. Then for imaging, Kelly has been pushed into the PET camera or SPECT camera. So taken out, taking the readings, and then the image formation. See the gamma camera. You see the thyroid scan. One thyroid is okay, another thyroid is having trouble. Liver scans, lung scan. One liver is getting affected. You see, this is the bone scintigraphy. Okay, this is either with a thallium or it's taken. So where this is bone cancers and other, where it is getting affected, that activity is very high, and other actually that indicates malignancy. PET is actually here, the radioisotope is injected. This is the radioisotope, which is there, like you take this FDG fluorine 18. Basically, it is a positron emitter, beta plus. I told now, beta plus. This this annihilation radiation takes place. Annihilation means this emits gamma. That gamma undergoes annihilation into beta plus and beta minus, having a energy of 511 kV, and you have throughout that you have full 360-degree detectors. So what happens if radiation is emitted? Since it emits actually two photons like this, so you are getting 511 kV of gamma, 511 kV of gamma 2 gamma photon in both the directions. See, either they can be beta plus or beta minus, but in case of beta plus, in say beta plus is only you have the positron annihilates. In the case of FDG, it emits I told you gamma, sorry, it emits positron, and the positron annihilates to two gamma rays in 180 degree, and you will get two detectors are sensing the gamma rays. If it is signal is getting from two detectors 180 degree apart, then it's a very good signal. Yes, it's certainly a portion which is coming from tumor only. So they can confirm it. This is helpful in the image process. Okay, this is the plane of radiation. See, this is the plane actually where the tumor is and all that actually. Here you can see the imaging. Doctors can identify so how much of damage is done to the particular organ and all that. And future prospects. Potential growth is due to awareness in food safety, increase in global trade and food supply chain. So awareness in food safety already we told. Global trade, necessity for extending the shelf life. So we have to reduce the reliance on chemical preservatives. So new technologies are coming, and government and regulatory supports are there nowadays. Huge amount of support is there. So of course, you can sustainable food systems by minimizing the resources. So if the spoilage is less, definitely the water, land, and energy resources are minimally. You can reduce the usage of resources. So these are the future prospects. Based on that, actually, lot of things are coming. Actually, areas of potential growth: controlling pathogens to improve export. You need actually a lot of exports are going on, food products and other things. So the export standards are very stringent. Even the countries of importing, actually, they are very stringent in the amount of pathogens and other. So huge amount of market is there. And similarly, decontamination of spices and herbs, and reducing the salmonella and other pathogens in meat and poultry. In case of seafood and ready to eat food, now everywhere everybody is using pet foods and other pet foods and dog food and other things. Bright prospects are there actually, this radiation perspective. Now I will give you a few of our future developments, our Department of Atomic Energy. Just I will show you, these are recent developments. Almost it is installed. That commissioning inauguration of low temperature irradiator. It's irradiator only, like any, this is using a cobalt 60 source only, but it is kept in chilled air, means cryogenic things. So for fresh fish, 30 degree to 10 degree, and for frozen fish and minus 18 degree to minus. So while irradiation itself is kept in chiller air unit, so that the cold chain integrity. So the sample's cold chain integrity should not be disturbed. That's the main thing. So this is already developed and commissioned by Board of Radiation and Isotope Technology. Another thing which has design approval is over is a mobile irradiator unit. Just see. It's a truck, 40 feet trailer truck bed. Different places. You can use 100 kilocurie of cobalt 60, and it can have a what do you call throughput 9.6 megatons per day up for mango, and 14.5 megatons per day. This many tons of samples are analyzed per day. For disinfection of cereals and other 14.4, for mango 9.6. Its design is approved. You can see shielding is there. Radiation is radioactive source is housed inside the shielding. Control unit is there. You have the conveyor type is there, what you call scissor lift, and it goes and it is working on diesel generator and all that. So I will finish it. There is I have 3 more slides only. Okay, and during this Himachal Pradesh flood and landslide affected people, our department, that means the Department of Atomic Energy, has preserved radiated food. Actually, they have sent actually, which is called liti. Liti means it is like some basin or what you call gram flour, say gram flour, gram flour, kadala paruppu. From that actually it is prepared food and other than North Indian peoples used to take, and it can be shelf life of 8 months if it is unopened and all that. Lot of few things. Liti consignment of 350 kg was sent. And again, recently in December 2024, 5 cereals and 3 oil seeds BRC released actually. Collaboration with universities and other things, 8 new crop varieties. They such as gamma rays or electron beams, irradiation for genetic changes to develop climate resilient, not genetically modified, high yielding crops that are suited for India's diverse agricultural conditions. And challenges, consumer perception is there, cost effectiveness. See, if you want a small project, it is not suitable. If you are in higher means, if you a larger project and all that, it is cost effective because initial cost is high, running cost is not that much. Public opinion and advocacy groups are there, people are there to always oppose. Competition from alternate technologies are there, like Dr. Anand was telling about cold plasma. Cold plasma, I do not know how come it will come in large scales, whether it will be possible or not. Hopefully soon it will come. Strict regulatory compliance is there, but anyhow compliance are all now taken care and then people are following. High initial cost, public perception, small mild changes in sensory properties, regulatory issues, same thing. Another irradiation resistant, like halobacterium, Dinococcus radioduranus, this type of bacteriums and bacterial things and other, they are irradiation resistant. They produce toxins. Nevertheless, these bacteria are not very common. So these are some uncertainties and things. Hope I have finished. These are the references. Thank you very much.
Yes, sir. So very informative talk, sir. 1.5 hours. He didn't stop anywhere. So yeah, it's new
You can
things.
ask some questions. I have actually, according to their schedule itself, 6 minutes is there.
Yeah, 6 minutes.
So you
is
can
there,
ask.
sir.
Somebody wants some questions. You can ask.
Yeah. That Mr. A.K. Sharma, he has posted many questions. So instead of reading Mr. A.K. Sharma, you can interact with the sir.
Yeah,
Are you there in the line?
Please make your mic on and then please ask. You can
Mr.
send
A.K.
the questions to me also. Mr. Sharma, you just ask a few questions. You can, I will give my Sarko, I will give my mail ID. Probably he may be having. So you can, for detailed answers and all that, I will send through mail. And for short answers, I will answer now itself.
Yes, asked. Are you there in the line, Mr. A.K. Sharma? Okay, sir. Maybe I'll read that questions. Okay,
we
sir?
can discuss here.
Yeah. Radiation is about the absorption and effect of radiation on matter or living tissue. This is the question,
No,
but
wait,
it's not.
1 minute, 1 minute. What he is asking, let me try to find out.
Yeah, you can also read, yes, sir.
Could you hide that tab? No. Okay. Radiation dose is about the absorption. And okay. I asked a question, and so he has given. Anyhow,
Yeah.
since I could not see, I asked the difference between a radiation dose and
Okay. Yeah.
so and the radioactivity. So he has answered it actually.
Okay.
Okay.
Next question is radioactivity measures how much?
Yeah. He has asked. Next is grays or sieverts. He has asked. I'll tell you the difference. See,
Yeah.
normally in radiation protection units, we call it as sieverts because one is radiation absorbed and radiation utilized in the body. So if the radiation just absorption, radiation delivered or radiation absorbed, absorbed is only gray. That is what we call it as absorbed dose. But other thing called uh, uh, equivalent dose. Equivalent dose is expressed in terms of sieverts. Observe, both are all in SI units only, this modern unit. The old units are rad and rem. Okay, gray, GY or sievert. You see, he has mentioned in the chat I am seeing. Sievert is a unit for equivalent dose because different radiations like alpha having different weighting factor. So accordingly, the equivalent dose differs. So, but nevertheless, in irradiation, it is expressed in terms of grays and kilograys. Okay, next I will move. Radioactivity measures is how much of radiation substance produces, while radiation dose, how much a substance produces, not exactly. Exactly, the radioactivity is, I told you, the unstable elements of their isotopes, these isotopes of these unstable elements, they emit radiation. By emitting this one, they're trying to stabilize. That means I told you cesium is decaying to barium. So our cobalt is decaying to nickel. So they disintegrate. So how many disintegrations are taking place per minute? So that is what you call activity, radioactivity. The radioactive substance, if you keep in front of you, how many disintegrations are taking place? How many times it is emitting? Each disintegration is emitting, we just assume for a sake actually one ray or one particle. So how many particles are emitted per second? What you call, this is what is called actually radioactivity. It is expressed originally in terms of Curie. Nowadays it is becquerel. One disintegration per second is called DPS is called 1 becquerel. Curie is a much higher unit. 1 Curie is 3.7 10 to the power of 10 becquerel and all that. It's okay, old, that during actually, Becquerel and Curie, Madam Mary Curie and Becquerel, who is found out actually the radiation, Mary Curie and her husband also, they have lot of detection of discovering of radium and discovering of polonium and other things and all that. So that's why it is old units are Curie still is expressed in Curies and other, but new units are expressed in becquerels, gigabecquerels and other. Any good books for radiation? I will tell you some links actually. Okay, I'll send through SAS actually which are available. IAEA publication. If you go into the site of International Atomic Energy Authority, IAEA. IAEA site, many things are public. In the public domain, there are many documents are there. Radiation and safety IAEA publications, you just give, there are few are there. You can read, this is for common public itself. Our Department of Atomic Energy has also issued, but now I have to check the link. If I get the link, I will send it to Dr. Mariappan, Professor Mariappan, and you can get it.
Yes, sir. I'll forward to.
So actually there was a network issue in between.
No, sir. It's going fine, sir. Yeah, it's going fine.
Sir, free radicals produced during irradiation will cause any nutrient degradation in the food. Yes, because these free radicals, they produce, I told you, H2O2. Say they produce oxidation. H2O2 is hydrogen peroxide, hydroperoxyl actually radical we call it actually. Yes, but they are all what do you call? Actually, that is why as we grow older, we have a lot of free radicals present. We have to take antioxidants also. So this reduces the free radicals production in our body. So as we go, our absorption of nutrients also comes down. Yes, it is true to but a smaller extent. Neutrons have better penetration. Are they any useful in applications? Yes, but neutron having a very highest disadvantage. Neutron can activate. I told you one thing repeatedly. This irradiation does not cause any radioactivity inside the material. But this is not true for neutrons. Neutrons more than high MeV definitely creates induction of radioactivity in the material, which is it is irradiating. In our body, if you are getting exposed to neutron radiation, it induces radioactivity inside our body. It makes our calcium, it makes our what you call potassium and other elements which are present in our body radioactive. So neutrons are generally not used actually. You mentioned electrons and positrons. What are the applications of E plus in the agricultural food? See, positrons are generally not used, and positron emissions are used in medical applications. Electrons, as you told, electrons are electron therapy. It is used actually. And how can one differentiate radiation and non-radiation products without labels? Yes, it's very difficult because they don't contain any. It's a radiated food only. Unless they mention it, it's very difficult. But some thermoluminescent methods are there. By passing, see, what we do is dosimetry of environmental radiation. We do it. Similar way, thermoluminescent dosimetry can be done on this irradiated and non-irradiated product, but they are all very what you call fine. You cannot do it as easily. You require a very large setup of laboratory, high precise instruments and other to do that. So definitely labeling is very important. Are there any positive effects of gamma radiation on cooking time? And this is already I have mentioned it. Actually, cooking time and all that I have given ripening or somewhere I have given. Actually, you see, I have given mentioned it. Can gamma rays are used on milk products and other liquid products and all that actually. Normally, milk pasteurization is only done. Yes, for test sake have been done. I have heard it, but I have never seen a commercially things and other. Other liquid, there are many other liquids. Gamma rays are used for different purposes and all that. Any more questions, sir?
Yeah, participants. Sir, actually, I have visited Park Baba Atomic Center, Bombay. We had one project that is called this technology dissemination division. They have given the technology to us to disseminate the technology of
technology
biogas
transfer,
plant.
technology dissemination in a transfer division call.
Yeah. That is about biogas plant and other small equipments. That is a water purifier.
They produce actually what you call this water purification membranes actually.
Yes, sir.
So,
Yes, sir.
in fact, the technology is transferred to many private companies also for
Yes.
this what do you call reverse osmosis membranes actually.
Yeah, reverse osmosis membranes. So during that visit, I have visited this facility, sir. This solar
Yeah, you might
irradiation
have visited
facility.
Dhruva, you might have visited. Dhruva
I have
reactor.
visited, sir. Yeah.
Hmm.
So how
I,
like that?
I'm head
How
of,
many facilities
hmm.
you are having, sir?
Sir, we are having more than 12, 13 facilities are there. No, not that type of
Okay.
facilities. DAE facilities
Okay.
are so much, but basic research facilities are 5 or 6. Actually. Like, Baba Atomic Center in Mumbai, Variable Energy Cyclotron Center in Calcutta, uh, um, Ramanna Center for Advanced Technology, that is in Indore, and IG car in Chennai.
Kalpakkam,
Chennai means
yes.
Kalpakkam. And you have Indian Plasma Research in Ahmedabad. Then Institute of Physics in Bhubaneswar. There are like that facilities are there. And other
Yes,
than
sir.
that, you have about 22 nuclear reactors, which is also coming under Department of Atomic Energies.
Yes.
They are all coming under Nuclear Power Corporation of India Limited. Okay.
Oh.
Then for producing isotopes, we have Board of Radiation and Isotopes Technology. That is also a part of Department of Atomic Energy. So that produces these food irradiators, blood radiators. Yeah, commercially you can buy it. Actually. People can buy food irradiated. They can buy blood irradiated. They can buy for sample irradiated. They can buy. They can even produce radioisotopes for uh, mm, uh, those who are setting up food irradiated facilities. Food irradiated facility, government facilities are 1 or 2 only, but most of them are around 25. Most of them are private and semi-private. In Tamil Nadu, I don't know. I heard something about Kayataru, something like that. Is there?
Kaitar in Tamil Nadu,
Kayataru.
Kaitar is there. Yeah, is there.
And in Chennai or Coimbatore, Theni also some food processing facilities are there. I heard of them.
Okay.
I'm not very sure about it because should be familiar because most of my work is on radiation safety and radiation shielding, as I told, experimental radiation physics as well as theoretical radiation physics. Though I am a safety in charge, I am involved in that. Still, I am. There is a Saha Institute of Nuclear Physics is there in Kolkata. So it is similar to Tata Institute of Fundamental Research in Mumbai, actually. So that Saha Institute, still I am there in the state, still I am continue to be there. There is a facility called Facility for Research in Experimental Nuclear Astrophysics called FRENA, which is very, very interesting project, FRENA. You can go through it, actually. People can do a lot of research on that. It's only one in things. I am still in the committee. Recently also they have again elected me back.
Yes, sir. Yeah.
So we can have a
very
lot of
interesting.
collaboration.
Yeah.
You can come over here. I am staying very close to Main Guard Gate, Tepakulam right now. I am taking care of my mother, though I am having some research publications also along with some of my collaborators. But as I assured my mother, after my mother is bedridden for the last 12 years, and I have assured her, I have given the word that I will take care of her after my retirement and all that. But I am still active.
Yes, sir. Sir,
Thank you. So nice.
very
You have
interesting.
conducted very nicely.
Yeah, thank you, sir. Actually, we can discuss a lot, but another speaker already in the line.
Yeah.
So,
Okay. Sorry.
No problem, sir. No problem. We will formally thank you. Joel, yeah, please thank the sir.
Okay. Thanks.
Yeah, thank you.
Thank you.
Extend our heartfelt thanks to Dr. Raman Ravishankar for his outstanding presentation on the topic food preservation using irradiation techniques and its other societal application. His in-depth knowledge and clear explanation have provided us with a comprehensive understanding of the role irradiation plays in food preservation, from enhancing shelf-life to ensuring food safety. Additionally, his insight into the broader societal application of these techniques, ranging from improving food security to supporting sustainable agriculture, have left us with a deeper appreciation for the potential of innovative technologies in addressing global challenges. We are grateful for the time and effort Dr. Ravishankar sir dedicated to sharing his expertise with us. His section has undoubtedly sparked curiosity and inspiration for all of us to explore and apply these advancements in our respective field. On behalf of everyone present, we offer our sincere thanks for such an engaging and informative workshop. Thank you, sir.
Thank you so much, sir.
Thank you, sir.
Yeah, yes, sir. I think other next speaker is there. Anish sir, Anishima sir. Mr. Anishima sir. Is there in the line? I'll call him. Please wait. So next speaker is joining in a moment. Good evening, sir. Sir, able to hear me, sir? Hello, sir.
Sir, can you please turn on your mic, sir?
Sir, Anish sir, just you turn on your mic and then speak, sir. Yes, sir. That would be better, sir. You can repeat. Now also not coming, sir. No problem, sir. You take your own time. Yes.
हाँ नवंबर से बुला रहा है वो। नहीं डाल सकते बिल्कुल, तो सब चीजें हैं, तो वहां से अपना होगा तो कोई दिक्कत नहीं, वहां से ज्वाइन करें।
No, sir. We are not able to hear you, sir.
Sir, can you hear me now?
Yes, sir. Now it's fine, sir.
Oh, sorry. Okay. Yeah.
Sorry to trouble you, sir. Yeah. Finally, we got it. Yeah.
So,
Okay, you can just check the screening, sir, whether you can you're able
sure,
to
I'm just
present.
checking.
Yes, sir. Yes, sir.
Are
It's
you
come.
able to? Okay.
Yes, sir. Yes, sir.
Shall,
We will
shall
welcome
we?
you, sir. Joel,
Yes, sir.
you welcome the sir.
Oh, okay, sir.
Yeah.
Good evening, everyone present here. It is my privilege to introduce our esteemed speaker, Mr. R. Anish Simha, Assistant Vice President at Renac India Limited, a leading company in cold chain solutions and food processing infrastructure. With extensive experience in food processing, cold storage technologies, and industrial refrigeration, Mr. Simha has been instrumental in driving innovations that enhance food safety, extended shelf life, and maintaining product quality. His expertise in modern food preservation techniques, cold chain logistics, and hygienic food processing infrastructure has contributed significantly to the industry. Today, he'll be sharing valuable insights on enhancing food safety and quality through modern processing techniques. Please join me in welcoming Mr. R. Anish Simha. Sir, the session is yours now.
Okay. Thanks a lot. Thanks for the information and introduction. Since we have actually lost a lot of time and I don't want to further delay, we'll proceed with food safety. Basically, we are a refrigeration and cold storage company. So for us, the introduction slides, what I'm going to show you now is the information what is available and most of you here will be knowing because this is directly related to food safety. Then we will go through what are the safeties we need to consider in the refrigeration for preservation of the codes for the products. Now, to food safety and to meet the quality is the intention for every customer, every person who is in business, and also people like us who consume. So, to meet our needs, the modern technologies are being implemented to have, see, the inspection technologies with machine learning capabilities. That means when you inspect the food before they are being packed, then of course the vendors, the manufacturers need to safeguard and protect their profiles. Then vendors need to protect their brand. They cannot lose their brand by giving a product which is not suitable. Then the vendors need to retain their loyal customers or consumers. So this is basically a general information where any a person from the industry, manufacturing industry, is looking up to. And my experience is we provide facilities to the manufacturers of food and food products, and we are not into the food industry as such. So methods now being implemented are product inspectors to detect harmful foreign materials with X-rays and metal detectors which are good at detecting metal or bones. But then it is difficult to detect low density or non-metallic foreign materials like plastic, rubber, wood, paper, and objects similar in color to the food product. These are the challenges which is currently being faced by the food industry. Then there are solutions like using artificial intelligence driven vision inspection systems to enhance the detection capabilities and operational efficiencies to meet the challenges of the modern production environment. Artificial intelligence inspection technologies address to the need with objective inspection process, otherwise which will be difficult to be achieved by human being. So artificial intelligent vision inspection systems require human involvement in training and maintaining these systems. The systems are also created by human being, but then uh, they we make these systems to work for us, but then manpower is required to maintain and to see, monitor the systems are working as per our requirement. So artificial intelligence can never completely replace human factor in the food production. So these are the few slides which I thought we will be sharing regarding the food safety. Then there is this food processing 4. I'm sure most of you may be knowing, since we are not manufacturers of food. So this information is available to all. Food processing 4th industrial revolution, they call it as, where technologies to improve quality and safety of processed food products, to reduce production costs and save time, to save energy and resources, to diminish food loss and waste. See here, we do contribute in all these aspects to reduce the production cost and time, then save energy and resources, to diminish food losses and waste. The demand for food will increase by the current rate what we have. It will be again further increased by another 65%, and then the data says that by 2050 the world will be about 9.7 billion in strength. So much people need to be fed. The need will be food with enhanced nutrition value, consuming fewer resources, preserving biodiversity, and causing low environmental impact. So this is all required to prevent food insecurity and hunger. Need smarter food processing, innovative strategies, technologies, and machineries. The high connectivity and automation assisted by computing power and the key elements that can revolutionize the food processing system. So everything is all being done by human beings itself, but then we try and use all machineries wherever possible, especially for detecting of unwanted items in the food, and then of course all the other machineries where we will try and consume less energy and utilize the resources to the maximum possible. So the industry 4, with many digital technologies and advanced solutions like artificial intelligence, Internet of Things, robotics, and smart sensors, have the potential to accelerate automation and digitalization in industrial sectors, including the food industry. So here I would like to make a point that though this uh, looks all the statements here what I have presented is from the information available on the net so far. So these statements, what I feel is, it is made in a way that it's very well understandable to all of us, but at the same time it's not saying that something has evolved all of a sudden. Most of the points given in industry 4 has been done by various companies as per their requirement at different stages in their production. But now what industry 4, what I see here is that they have combined all the points, and then they want all the industries related to the food industries, all the players in the food industries to start utilizing these resources and ensure that we have minimum wastage. So this is the inference what we can get from what is available in the information on internet, etc. So now coming back to our topic of today. So we have to protect the fruits, vegetables, then dairy products, ice cream or the frozen desserts, then dry fruits, seed, spices, dal, marine products, poultry and meat, ready to eat or ready to cook, then medicines, of course, raw materials used for FRP and GRP products. So these are basically in the aircraft industry and automation industry. Uh, then the warehouses or the third party logistics. All these all these products are we require to store them in the specific temperature and humidity, and the shelf lives are defined at the various temperatures. How long these products can be stored, it is defined, and we have the data, and accordingly we, as a cold storage turnkey solution provider, anybody in this industry like us, we are always striving our best to see that the losses in these products are reduced when they are being stored. So we need to maintain the specific conditions inside the room as required. So for fruits and vegetables, of course, like we all know, banana after ripening, the shelf life is 3 to 4 days. After that, we can't do anything. Neither can we keep it in a refrigerator, nor we can't do anything on that. It has to be consumed. Similarly, tomatoes. After the tomato is ripened, the shelf life is hardly 10 to 15 or maximum 20 days. So in tomato, puree is being made. So tomato is being used in two ways. One is directly it is used for cooking or eating after processing it, and the other one is we make purees. So whereas there are other items like we see here, dried fruits, seeds, spices, dal, and potatoes. So all these red chilies, all of them have a higher shelf life. And similarly, in marine poultry and meat, we do have both fresh produce, we can store them for their shelf life, or we freeze them and then we store them for a longer shelf life. So how we freeze them? So what are the safety precautions we need to take so that the product do not get distorted or destroyed is what we will be discussing today. Similarly, now the trend is for third-party logistics. They are the companies who will be storing for other manufacturers, and it is more common now with pharmaceutical industry. So most of these third-party logistics are storing medicines of various manufacturers as their rented go down, and then they will hire it for them. So again, there we require cold store. And the important point what we would like to share as a solution provider is there are, of course, we all know sensors which can be put into the product. Then there are room sensors, and there are temperature and humidity recorders. Then there are, of course, cameras, we all know. So everything is being monitored today, and it is being tested, and that's how the products are taken care of. So to do that, we have various process or stages. So I have selected a few products for which we'll go through in complete, and then similarly we will be this for the other products also. Similar process are being done now for storing the products in a safe way. So basically, for the marine industry, we require ice blocks, flake ice, and tube ice machines. Then we also require chilled water, or we require brine, chilled brine to store the marine products, some of them. Then for cold rooms and pre-coolers are required for fruits and vegetables, and of course the dairy products. Pre-coolers, we use them in 2 to 3 different industries. One is for fruits and vegetables, then for basically we do, instead of the pre-cooling, we also you do the blast cooling or the blast chilling, that is for the um, curd industry, or in the air flight catering industry. So there they use the blast chilling, and of course pre-cooling is done for fruits and vegetables, and cold rooms are required to store all these products. Freezer rooms is for all the frozen products, and how do we freeze them is through blast freezers or plate freezers, and depending upon the quantity of the product, an individual quick freezer can be used. And especially if it is for shrimps, we use a individual quick freezer followed by the glazing machine and then the hardener. So these are the processes which we'll come to know shortly. Then all these areas where these processors are taking place, they also have to be in a conditioned space. The air has to be clean, and also we need to maintain the proper temperature inside the room. And we require the refrigerated transport system to transport these. Then handling, cleaning, grading, sorting, packaging, and testing. So at every stage, the safety of the product is what is the prime concern, and we need to have the construction in such a way that the dusts is avoided, generation of dust, we reduce it to almost minimum external dust, and then depending upon the product properties, we need to maintain the humidity. Like for fruits and vegetables, we maintain a very high humidity, but when it comes to seed storage, we will always maintain a lower humidity in those rooms. So depending upon the product, the temperature and humidity will be controlled. Because when we go below 0 degrees centigrade, it is very difficult to control the humidity. So in commercial applications, below 0 degrees centigrade, humidity is not being talked of. That is in the commercial industry for refrigeration. This is what is being done today. So block ice machines, I'll just show you some pictures. This is how the blocks are ice. This, some people use seawater if it is for marine industry and to safeguard fish. And some people use for different applications, maybe the water can be clean water, but almost all of them, either it is seawater or clean water, you get ice blocks. So how they are produced, you can see there are these kind of cans. So the cans will be dipped in these slots, and in this tank will be a brine solution, and then there is a refrigeration coil kept here, so in which the refrigerant is circulated, and then this refrigerant will chill the brine, and the brine in turn will freeze water, and we get this ice. So there are mechanism where you can lift these cans, something like this, and then you get ice. So this is the one of the beginning stage where in the refrigeration system or the refrigeration industry player will start their work for fisheries. So they take these ice blocks and then they go for fishing. So there are many various quantities required, like 20 ton per day or 24 metric ton or 30 metric ton. They, depending upon the requirement from the customer's requirement, we have there are so many models in the industry, and then there can always be a non-standard designed to the actual requirement of the customer. The basic principle is the same, it's only the sizing of the equipments will vary. So this is how the evaporator unit, what we shown there, looks like. Maybe after another stage, this may be during manufacturing, and this can be after completion of the work. So in these evaporators, the refrigerant will always keep flowing around, and then they come back from the unit. It goes back to the it's a closed loop cycle, so the refrigerant always is moving in a closed loop cycle. These are how where the condensers where heat is rejected. I'm just showing you a few pictures. These are some shell and tube condensers, basically used in the marine industry. Some people use it for even seawater. They use just directly seawater is used, and heat is added to the seawater, and then this seawater is again let back into the sea. So of course, there's not going the water is being collected at one source, and the hot water which is going in to the sea, again there is a regulation which our customer, the end user, need to follow based upon the local government to see that the sea or hot water, when it is being put into the sea, they have regulations, and accordingly they take care. So these are how the flake ice machines, you can see these are flake ice like the coconut grating. So this is an flake ice machine where water from the top trickles down on the inside surface of this steel tube. So by the time it reaches this point, the water would have become ice. It will trickle down due to gravity, and then there is a cutter here, a blade which keeps rotating, and then it generates flake. These flakes are collected in the bottom, and they're used something, one application is like this. Then it can be used in many industries. If the water is food grade, then the equipment also will be food grade. Then ice can be used for consumption, ice can be used for packaging. So there are many applications for these. And then these are called as the tube ice. So flake ice was like gratings, tube ice will be in tubular form. So similarly, water is made to flow down here, but here it's not on the surface, but then there is a tube. There are tubes to the tube sheet, which is be on the top, and water trickles down. And by the time somewhere it reaches here, it becomes ice. And because of gravity, the ice comes down, it falls, and then there is a blade which cuts. Depending upon the length, it can be 15 mm, 20 mm, 25 mm. Again, the application, several applications, they are used for fish industry, or for packaging, or for consumption. So depending upon the kind of process, these are all used. So everywhere we ensure that the safety wise, the the material of construction is defined well, so that the food which goes into the human being, if it's going directly, then this will be with stainless steel, or if it is going to be cooked, then since it is going to be cooked, the water will be of food grade. So there are various precautions that is being taken care. And this is a summary for the marine industry. Similar for I have just presenting you some slides from the marine currently, but this is applicable for other industries also. It will be almost similar. So when we have to make block ice, my refrigerant temperature will be minus 18. So ice temperature will be in the range of minus 4 to minus 5 degree centigrade, or minus 7 degree centigrade. So then why is the huge difference? Because this refrigerant is not directly making ice. So there is a brine or water with salt whose freezing point is lower than water, and then that brine temperature can be about minus 10 or minus 12 degrees centigrade. And then with that minus 10 to 12 degrees centigrade, we freeze water to ice, which is at around minus 5 degrees centigrade. Similarly, for tube ice machine, there is no indirect cooling. There is a direct cooling tube ice machines where the temperature will be about minus 15 degree centigrade. And then this is the temperature of the refrigerant. So if it is IQF or hardening, the refrigerant temperature can be about minus 45 for IQF, and hardening will be about minus 5. Plate freezers and blast freezers, again you can see minus 40 degrees centigrade. Then flake ice or cold rooms, it can be, if it's a freezer room, it can be minus 25. The refrigerant temperature minus 5 can be for a cold room where the temperature is maintained about 0 or 1 degree centigrade. So similarly, these are the kind of refrigerant temperatures which we need to generate in the refrigeration system to get our products. So what is the safety or precaution we need to consider here is again about the energy which is being used and the impact on the environment, which we will go through in the later slides. So we were discussing about the refrigeration cycle. I have a few slides. I know maybe this would have been discussed by various other speakers, so I'm not taking much time. So we have a single stage compressor, because when we talked about minus 45, that will be the temperature of the refrigerant at the evaporator. And when it is a water cooled system, the condensing temperature in India can be about 38 to 40 degrees centigrade. So the job of the compressor required is to keep sucking the refrigerant in the vapor form at about minus 45, and then increase this temperature of the refrigerant to vapor to about 40 degree centigrade. So that is the work of this refrigerant compressor. But then there are limitations for these compressors. They cannot keep increasing the pressure at any ratio. So a single stage compressor has its limitations, say from minus 10 or minus 15, it will increase the pressure to minus 40. But when we require about minus 45 refrigerant at different applications, then we will have to go for a two-stage system wherein the refrigerant pressure is increased at two stages, that is an intermediate stage, and then it goes to 40 degree centigrade. So the third one is a booster and high stage compressor. So basically we have a single compressor body where you can differentiate the cylinders into two different stages, or have two separate compressors. So this is how basically the refrigeration cycle looks like. So the compressor's job is to increase the pressure of the refrigerant vapor, and condenser is where the refrigerant vapor becomes a liquid. So its temperature, it has to give out the temperature to the water which is used to condense the refrigerant into the liquid. Then we have an expansion valve which will again decrease the pressure which is required based upon our requirement and the evaporator. It can be minus 5, or it can be minus 25, minus 40, minus 45. So the particular expansion wall is all depends. You have to select them based on the capacity and based upon the input and the output pressure what you have. So there are many manufacturers, and then we have the data to select them. That is how the single stage or the two-stage refrigeration system works. And then how internally the refrigerant goes into the system. We have a direct expansion, which we've seen now with the thermostatic expansion valve. And then there is another system called as a flooded system. So all these, why we are discussing today is these are all required to save power and the environment. So these basically, when we use a flooded system or a pump system, the refrigeration capacities required will be higher, and then we will be using a natural refrigerant when we go in for a flooded system or a pump system. So first, we have seen a direct expansion. Now we'll be seeing what is a flooded system. This is a flooded system where from the condenser, we have a liquid refrigerant coming out. Then this is stored in the receiver. And then from the receiver, this goes into an this evaporator through a vessel, which is called as an accumulator. So the expanded liquid will get filled into this vessel and will ensure that always this coil is flooded with liquid. So this is through gravity. There is no other external force other than the pressure created by the compressor. The compressor has developed pressure, and with that pressure, the refrigerant flows in a closed circuit and comes back to the compressor. So here, why we call this as a flooded system is because you always will try to maintain pure liquid in the evaporator. Complete liquid will be maintained. So then how the heat exchange happens? Of course, the whatever liquid becomes a vapor that goes into this vessel, and from there it goes back to the compressor. And whatever the balanced liquid will eventually become a vapor. So that's how the cycle keeps rotating. But then basically the coil will be flooded with the liquid is what this system works. Here we have a pump system where from the receiver, the liquid refrigerant, after expansion, it goes into a larger vessel, and then we connect a pump to this, and then the low temperature liquid is pumped into all these evaporator units. So this is basically required where you have multiple chambers and multiple rooms, and then the distances are more. And of course, for the individual quick freezers, blast freezers, everywhere we use this pumped systems. And these flooded systems are basically generally used in chili stores, in cold storage for chilies, dry chilies, then cold storages for potatoes, where everything is fixed, the distances that and the plant room. So it will be basically one building and one plant room. Whereas here in pump systems, we can pump it to one or two buildings in that region, and then it can still give the same effect. So these are basically the kind of refrigeration systems that need to be used. And most important, depending upon the capacity, especially for a larger food industry, currently natural refrigerants are being used, and then the natural refrigerant are used are ammonia and carbon dioxide. More of ammonia in tropical condition today, and then there are systems with carbon dioxide which are being discussed at various stages with different customers. There is some amount of I can say at the moment hesitation in the market to go in for a CO2 system, which we will overcome. And then there are also technical issues that need to be resolved when we use a carbon dioxide system because of the pressures. And in tropical conditions, the condensing, the carbon dioxide will reach a critical pressure. So we don't want to we want to avoid operating carbon dioxide into the critical pressure region. So that's why we try to use cascade systems. So that is being implemented, and once these increase, the quantities of this kind of systems increase, then we'll be in a much safer conditions with reference to the operation and usage of the refrigerant. So compressors, I'll go very quickly on this. We have both reciprocating and screw. These are the methods of compressing the refrigerant. So a screw compressor is the latest technology, and you can see this is how the refrigerant is pushed. Whereas in reciprocating, it's a piston and a cylinder. So it's like how we have in many other automobile industry, the same procedure, air compressor, where we have pistons and cylinders. One side we suck the refrigerant, and on the other next cycle it is pushed out. Whereas in screw compressors, you have one moving part and the one is the stationary. That means it will also be moving, but then it is more rotating with the bearings. There is no other energy given here. Only one is called as this is the driven one, and this drives the other one. So this is where you have the energy. So here, by the time the refrigerant comes out, by the time it moves into these lobes and comes out, the pressure would have been increased. So there are advantages for screw and reciprocating. If the system's capacity is smaller, where the plant size is smaller and the refrigeration load is smaller, then the reciprocating compressors are preferred. And for larger capacities, screw compressors are preferred, and they're also available in the market. So this will give you a larger capacity and it will occupy less space. Reciprocating compressors do have limitations with reference to the refrigeration capacity by a single compressor. So when we talked about the refrigerants for being safety to the environment, you can see we have natural and synthetic or man-made. So ammonia, carbon dioxide, then hydrocarbons are basically the natural refrigerants which are being used currently. And then we have the synthetic refrigerants. We have CFC, HCFC, HFCs, and HFOs. So the most important thing today means at this time is almost all the refrigerants are having zero ozone depletion potential. The point which is of concern to us is the global warming potential. So currently, wherever possible, and depending upon the refrigeration system capacity, we will have to go in for either an ammonia system or ammonia and CO2 for large food industries, because there the refrigeration system capacity itself required will be on a larger scale. In smaller systems, still in our country, we are using 404A, which actually has a very high global warming potential compared to the other similar refrigerants. So there are other refrigerants which are substitutes for 404A, but there's currently being manufactured and sold by the manufacturer themselves. So they are becoming popular, but then again, it's a commercial aspect. And then in India, we still have some time to phase out 404A. But we are actually going ahead in many other refrigerants ahead of date, what we have committed. So this is what I would like to share about these refrigerants. So we have petroleum-based refrigerants, but then we need to limit the quantities of the refrigerants per system. So for smaller systems like refrigerators and small ACs and maybe small refrigeration units where the capacities are within 1 TR, then the petroleum-based refrigeration systems are also being used if they are suitable within that particular operating conditions. So this is what I wanted to share regarding the refrigerant. So when we See, typically when we discuss with customers, we will all sign off a document which gives up all these conditions which are fixed, and then the design is done based on these. So ambient is important to us, and the temperature in the room. So this is a flake ice room. So this is a room where we are going to store the room at -5 degrees centigrade. So then the room sizes, insulation, what we are using. So this is a standard technical sheet which we share. And then basically this is again done when we manufacture the insulated panels. Also, it is again manufactured with green refrigerants, and wherever energy can be conserved, these are there, and then there are ratings provided for manufacturing of such. And basically now most of the industries are going in for green based refrigeration panel manufacturing. So this is a typical plate freezers where you can see this is a horizontal plate freezer. These are the slots in which the product will be filled, and these two doors, these are pure stainless steel. So this entire thing becomes airtight once the doors are closed, and then once the refrigeration system is switched on, within a specified time, the product inside between these plates will get frozen. So this is a horizontal. Similarly, if these plates are in the vertical, we call it as a vertical plate freezer. So here again, for food safety, the material of construction will be stainless steel, and there will be no rust allowed on any of these materials. So you can see this entire thing is of stainless steel construction. So these are how the chill room and the frozen room systems look like. So if the product is in a packed condition, then we don't use stainless steel for the construction of these units, though they are always in with the product, but the product will be in a packed condition. Human being cannot touch the product because it's already sealed. So in such conditions, material of construction need not be stainless steel, but of course they will be painted well such that they do not rust. You can see this cold stores, when you maintain temperature of 4 degrees centigrade, there can be more condensation happening, and then moisture. Sometimes the product itself generate moisture. So the room can be moist, but still all these, whatever we are using the materials here for the construction of the room as well as the exposed units inside will be considered. So that is how these safety precautions are being considered for the safe store of food products. These are some of the pictures of our customers where they were storing, they have frozen the fish and other marine products. So this is a typical cooling coil used in an individual quick freezer. And this is a double impingement, in the sense air hits the product from the bottom as well as from the top, so that the entire fish is frozen by the time it moves inside the individual quick freezer. So at the inlet of the individual quick freezer, it will be fresh fish which was being from the sea or from water. The fish is, after fishing, it moves in trawlers which have ice water, and then after they are cleaned and inspected, then they are fed into the conveyor. So this is the outlet of the conveyor of an IQF. So at the inlet, the fish will come through a conveyor, and then there are people on both sides of the conveyor working there to identify any fish which should not be, which is not good, so they sort it off. So that is how the safety precautions are being taken. And then basically in case of fish, some of the fish, first we freeze the fish, and then especially for shrimps, we do the glazing. So the glazing is nothing but the frozen fish is passed when it is moving through the conveyor. It will be again be dipped with water, and it will not be there in water. It just moves around, comes out, so that on the product body there will be uh, it will be wet with water. So again it's hardened. So the basic idea is to protect the shrimp from any damages by building a thin layer of ice around the body. So that is how it's called as an IKF, where we freeze, then the glazing machine, and then the hardening machine. So this is how we have various capacities in the market: 50 kg per hour, 500, 750,000, and of course, non-standard products are also available. So this is what you can see an IKF, especially for this shrimp. So fish enters here, fresh fish. Then by the time it comes out frozen. So there is a set time, like we said, 200 kgs per hour. So the dwell time is what we call the individual fish or the shrimp. By the time it has to be within this is designed, and then accordingly the speed of the belt is adjusted so that the product is exposed in this region for that particular time. And by the time it comes out frozen, then it is dipped in water and then again put into another similar freezer, where the outside water, whatever is on the surface of the frozen fish, it also becomes ice, and then it is packed and dispatched. So that is how it is there. That is a straight line, and then of course we have the spiral, as the name itself say indicates. Product enters through the conveyor, then it moves around this way to the top, gets frozen, and then it comes out. So there are the application wise for different types of products. We use either the straight line or the spiral, and in fish, the double impingement is also used. So once the product is frozen, then the challenge is the storing. So how to store? So we can construct rooms of various sizes, and then there are provisions where you can expand the room size. But then with the current land prices, every inch, I can say, or every square meter is very costly. So we'll have to work out the best option of storing the products and not uh, getting spoiled or damaged, and then we should be quickly able to retrieve the product. So all these are the challenges which the industry faces currently, and then there are solutions for that. So this is the storage, what are the challenges and how they are being catered to by. So these are the challenges, that is the cubic meter space utilization. And then when you go for a proper storage, you get a very high utilization of the space. Then you can see them, the solutions, when you have high human interaction or pilferage or expired food, then all these are not there. You can use the first in, first out system. So less number of people, most of them will be used with material handling equipment. So these are the various challenges and solutions displayed here. So what for the dairy, see, we have to store ice cream, we have to store milk products, that is processed one. It can be maybe buttermilk, cheese, butter, anything, paneer. Then of course you have butter separate and ghee. Ghee may not require a cold storage. It doesn't require a cold storage, but then there is a room which is maintained at high temperature. But again, when we have to maintain any temperature other than the normal temperature, we spend a lot of energy. So we insulate the room to minimize the energy loss. So then how are they stored? Most of these products, including fish or meat, they all are stored in cartons, and then the cartons are assembled on pallets. So this is internationally how all these products are stored on pallets, and this is how they are handled. So then how inside the store you can have various types of storage systems for the products. These are called as the mezzanine systems, where you construct ground first, where you use them with everything with metal, and you avoid cement, concrete, columns, flooring, and so many things, because especially when you are storing cold storage products, these will be perforated flooring, because air has to move, keep circulating. If you store the same product at different heights, and then you have to have the air circulation. So these are all perforated kind of storages. So sorry, yeah, this is again the mezzanine kind of storage, and you can see them how it is being designed. So the solution provider will discuss in detail, in depth with the customer about the packaging and such things, and then we come out with the solution. So you can see how the pallets are stored. This is a double deep. Double deep means you can, from this place, you will reach the first one and the second one, only two. And from there, you will reach this first and this second. So in between, you will have to have an aisle space or an open space for the vehicle to move around. So especially if it's a forklift, then minimum we require around 2.5 to 3 meters. In some cases, it can be 3.2 also meters. So this much of space, 3.2 meters space all around, full length after every four storage spaces, you will be requiring a gap. So that is called as aisle space. So this is the storage space, and then you have the aisle space. So this is for a double deep. But then after that, we got this solution where you have a mobile pallet tracking system, where you can push all the pallets to one side, and wherever you want to retrieve the material or stack the material, you create the space only there. The rest will be moved, pushed together. So we enhance the storage capacity. So these are all the precautions which are being taken. So there are, how do we reach the second one is you should use this kind of material handling equipment with arms which are used. So this requires space. So this has to move in a straight way, and then for loading and unloading, it has to turn like this, the vehicle. So there you require space, whereas the same space is required, but then you can push them together and you will have more product when you go for a mobile pallet system. So this is the video how the mobile pallet systems are being used. So here also safety is looked into, safety factors. So the products should not fall off, and then machinery will not get stuck. There are sensors, injuries are very rare and very less. It is all automated. So those are one kind of storage system. Then you have the drive-in racks. There's a fixed one, which you have already seen how the vehicle can move in and go. And this is another interesting kind of storage where you have this shuttle. This is a shuttle, so this can move around till the end, and then it picks up the material, and you can again take it through a material handling equipment. So there are many uh, methods here for storage, a lot of solutions depending upon the customer's need and the requirement and what he can afford, what kind of system he's ready to invest to get a faster turnaround of the products. So these solutions are available, and the customer, we help customers in choosing the actual solution what they required for their product. So this is how I was telling you what the shuttle is, and this video I think show you how the shuttle moves. See, that's the shuttle. Only is lifting the shuttle, and now the shuttle is positioned there. There are railings for the shuttle which is being installed. Then he moves the shuttle inside. It picks the products and comes back. So the shuttle and the product gets separated. The same shuttle can be used. Generally, customers will have some 7 to 8 kind of shuttles so that they'll be always in use. So that is the storage using shuttle. And then regarding construction, for very large cold stores, what is being done nowadays is the storage space is first built, and then it is cladded with insulated sandwich panels. So there is no other requirement. There is no civil work. Human dependency is very less, and it saves time to install these kinds of systems. And of course, they have insulation, so it's a very good solution which saves in energy. So these are some of the highlights. When you go higher and higher, you will have 100% utilization of the footprint. And these kind of solutions are there. And this has already been there in our country itself. Many customers have used them. And this is the automatic storage and retrieval system. Here, earlier you were seeing we used to leave around 3 to 3.2 meters space for the vehicle to move, but now every aisle will have a crane. So then there will be products here which will be moving on either going inside the room or then coming out of the room on conveyors. So conveyors will be moving in, so there is no human being going inside. These are all programmed. All of them are having barcodes. So the crane is programmed to pick up this when the material reaches from the conveyor at this point, it will go on position, and then there's a record of which product item is where. So it's fully computerized system, and that's why it is called as automatic storage and retrieval system. So this is the latest, and it saves refrigeration load because there is no light required in people moving. There are no big doors. There is no air infiltration to a very large extent. Air infiltration gets reduced because the door will be only equivalent to the conveyors width and the product height. So we are saving a lot of energy when you go in for this kind of storage system. This is how it is being done. And when it comes to, we have this video which it is there even in our website, so I'm not going to go through that now. These are the last few slides which I'm just concluding my presentation. These are the insulated sandwich panels where you use this kind of cam locks to lock them and make them airtight when we are constructing any room. And in between is the insulation. It is a polyurethane based insulation, and these two are metal finishes. It can be a pre-coated galvanized steel. It can be anodized aluminum, or it can be stainless steel, depending upon the customer's requirement. These sheets and the product requirements, the sheets, material of construction of the sheet will be considered. So one point what we would like to highlight here is there is no metal to metal contact from inside to outside, and all these are plastic material, because we do not want a conduction to happen. Inside I may be maintaining minus 45 degrees centigrade, and outside will be say in Bangalore it can be about 30-32 degrees, it can go up to 35-36. So there is a huge temperature difference from inside to outside, and if it's Chennai, the ambient goes to 45 or 43 degrees centigrade. So then if there is a metal to metal contact, here you can see initially condensation and then a lot of ice formation, because inside we are maintaining minus 45. So this one precaution is being considered uh, when we are installing such kind of rooms and manufacturing the panels, that there will be no metal to metal contact from inside to outside. So any item we need to suspend, we always use pull threaded rods which are made up of HDPE or plastic. So it's not anything with metal. So this is the other method of panel manufacturing. So that is with cam lock, it's a discontinuous line, whereas this is from a continuous line. We get this kind of sandwich panels where you use them where the production capacity are very high, and then there is no cam lock, but you get a tongue and groove fit. So these are also airtight, and in some of the applications, for especially for apples, we use these kind of panels for gas tight chambers. So why we use gas tight for storage of apples? Apples storage is called as the controlled atmospheric chamber. That is one form of storing apples. And these controlled atmospheric chambers will be very close to the place where the apples are grown. So there we would like to maintain the apple in a condition which will retain its humidity or moisture content in the apple, its taste, texture is also we want to maintain, but for a longer duration, maybe 5 to 6 months or sometimes 7 to 8 months. So how do we do that is we would like the activity in that apple to get reduced. That means we want the apple to breathe so as less as possible. So we in the room we will have inert gas nitrogen, and we will not allow the apple to suffer. So minimum basic amount of oxygen is being supplied, and as apple breathes it gives out carbon dioxide, so we remove carbon dioxide if its content of carbon dioxide goes beyond a set limit. So this is all we do. So that means we are actually controlling the gas in the room. It can be nitrogen, oxygen, and carbon dioxide. So it has to be airtight. So this kind of panels are used. This fit either cam lock, or it can be this on a continuous line, which is called as a press fit panel. Both are used in controlled atmospheric chambers. But then there are other special precautions which are taken to ensure that these are gas tight, like gaskets, such things will be used. But still, we maintain the uh, percentage or ppm of nitrogen, oxygen and carbon dioxide in these rooms. So these are the machineries which manufacture these kind of discontinuous and continuous panels. I'm just taking a few photographs. So here we make the discontinuous panel. That means the length or the height when you make this stand vertically, the height or the length of the panel is fixed depending upon this jig what we have. And the width is also fixed here depending upon the jig. So we make panels on both sides. The panels are assembled, and in the center portion is where the press is. Here you can see the press. So we'll compress the panels by applying pressure. So why do we apply pressure? Because this polyurethane foam panels are made up of two liquid chemicals, polyol and MDI, and when we mix them with the required catalyst, it solidifies and it will start filling the space. So once it is filled, we will apply pressure on these panels for a certain time so that the refrigerant, the expansion of the panel is under pressure, and then it will happen in the entire panel, in the entire space between the outer and the inner skin. So that's why we manufacture, the panels are manufactured here, and the cam locks are also fixed in position. The other method is this continuous line, wherein you can see there's a top sheet and the bottom sheets. They're from coils. This is coming directly from the mill. They're fed into this machine, and you can see this is the top sheet and this is the bottom sheet, and then this is the gun. As I mentioned, polyurethane will be liquid and then it will start solidifying. So this is solidification has just started. This is a photo taken at one of the stage in production. So the gun will be somewhere at this point, and then the metals will be pulled along. So again, here pressure is being applied. So by the time it comes out, you get long insulated sandwich panels, and there is a cutter here. So here there is no restriction on the length of the panel. The restriction will be only based upon the transportation facilities. So that is how this is how they are looking into sandwich panels. You can see how quickly the rooms can be constructed, and these are the kind of the precautions that are being used. So these are a few pictures. You can imagine the height is around 35 to 40 minutes. So with this, I'm concluding today's session, and we started at 8 o'clock. So I just concluded it now. If there are any questions, we can take a few.
Yes, sir. Thank you. Thank you for your nice presentation. Maybe participants, do you have any questions? Sir, I have some couple of questions, doubt. So we are using evaporator.
Yes.
So in that evaporator, how we are ensuring that the liquid is not entering into the compressor? Because yeah,
That's a good question, sir. See, if you have seen the refrigerant entering the flooded evaporator is from the vessel. We have an accumulator. We call it as an accumulator. The accumulator, from the expansion wall, the refrigerant enters the accumulator, and from the coil, it comes back to the accumulator. So in the accumulator, because of gravity, the liquid will settle in the bottom, and the top portion of the accumulator will be vapor. So we are taking the connection to the compressor from the top of that accumulator so that the vapor goes into the compressor.
okay, sir. Thank you. And regarding this insulation, so just I have seen that there are ready-made panels for insulation.
Yes,
But yeah, but for different application, we may require different thickness.
correct.
So how we can
That is also
use the
manufactured. The jigs,
oh that is
we have jigs for 60 mm, 80 mm, 100,
okay
120, 150, 200. Everything is there. So depending upon the requirement, it will be done. In the continuous line also, in the first it will be set, the machine will be set for 60. So all
okay
orders of 60 mm will be done at one time, and then it gets changed to 80, 100. So that's how it
yeah
is being
yeah
made.
yes sir, I understood sir. So that only polyurethane insulating materials are used, or can you give some elaboration on that? What are the other insulating materials for cold
Okay.
storage system?
Yes. See, cold storage systems before polyurethane use was foam was used, we were using thermocol or expanded polystyrene. This was used earlier. Now also, very rarely people go for expanded polystyrene. Only thing is, the thickness of expanded polystyrene or EPS required will be more compared to
Okay,
polyurethane foam.
okay, okay,
And the density of polyurethane foam is better, and its insulation properties are better compared to expanded polystyrene. So that's why polyurethane foam is used. And in polyurethane, there are two different types. One is the puff, which is being used, and the other one is polyisocyanurate, PIR. One is PUF is polyurethane foam, other is PIR, which is polyisocyanurate foam. So polyisocyanurate foam has a better fire properties compared to polyurethane foam.
great. Okay,
Okay. Since they are
okay.
chemicals, you can always imagine the fire properties of a chemical. Okay.
Yes,
Uh, so again, additives are added so that flames will not get propagated. They become self-extinguished, and so many things are being considered. But then when we do the installation, we take care that polyurethane is not exposed at any place. Okay,
okay,
so these are some of the things. And then the third point is polyurethane foam. When we make, we use pentane as an additive. So pentane is a natural refrigerant. It is, however, it is petroleum based. So
yes,
there we get green car credits for manufacture. Where vis-a-vis, instead of pentane, some people use refrigerants. Refrigerants are synthetic, man-made. So always a petroleum based, which is naturally available, will have more credits compared to synthetic refrigerant. So these are the uh, these are the developments, and still a lot of research is being always being done. And we being a turnkey solution provider, we try to use what is the best available material, and then see the customer always gets his best at this particular time. So that's how we concentrate on.
yeah. Thank you so much, sir. The elaborate answer. Participants, do you have any more questions? Sir, one question, Dr. K. Prasad, sir. The talk is very informative. Which is the commercial method in the storage capacity of cold storage, whether it is commercially classified in terms of tons of refrigeration or space. So that is this question, sir. So how we can specify the capacity? That is his question all about. Sir, your voice is not clear, sir.
No.
Yeah, now.
Specify the code. I didn't. Okay, see, I'm not. See, the application is very important here.
Yes.
Everything is commercial, but then when we see the application, see when a distributor wants to store medicines, so he will have a cold room, which we call as a walk-in cold room, which is very simple. The refrigeration capacity is also very less comparatively. The product load, medicine load is very less. But the same cold room, if we use it in a hotel, a 3-star to 4-star, 5-star hotel, then probably we will consider for refrigeration capacity about the product details, whether they're bringing in frozen meat or they are bringing fresh meat. So then the refrigeration capacity there varies, whether depending upon the product. Similarly, in an ice cream industry, whether the cold room is in the manufacturing facility or whether it is used for storage. If it is used in manufacturing facility, they use it for hardening. So there the load will be more. If it is used in storing, then already ice cream has been frozen. So this is only for holding the material. So we call it as holding and pull down. So these are one aspect to arrive at the refrigeration load. Second aspect is regarding the size of the cold room. Again, it depends upon the application. Whether you, if it is for a bulk product, then the capacity required will be huge. Like potato cold stores, they store in multiples of 5,000 metric tons, not 5,000 kgs, 5,000 metric tons, 10,000 metric tons of cold store. So if it's fruits and vegetables, it can be like 100 metric ton, 200, 300, 400 metric ton. So these are what we do. And then cold stores generally are not within the city because of two aspects. One is it has to be closer to highways where you have to have movement of material coming in from the areas where it is being grown. And second thing, the land costs are higher. And the refrigerant, for example, we use ammonia as the refrigerant, then it's preferred that it is not being used in place where more people are staying. So where you have in the city, we rarely find large cold stores. There in the city, we find cold stores for whatever we discussed now: medicine, hospital, canteens, then C&F agents for ice cream, food, etc. So in such cases, the requirement will be smaller, and there the refrigeration capacity will be smaller. And in such cases, synthetic refrigerants will be used. So this is the norm which is followed. I don't know whether I've answered the question full, but this is how the industry is working.
Yes, sir. Very elaborate answer, sir. Yeah. I think, I think no more question. So thank you, sir. Thank you for your time and effort. And we
Okay.
formally thank you, and my scholars will formally thank you, sir. Joel,
Sure,
or
sir.
yeah.
I'd like to express our sincere gratitude to Mr. Anish Sharma for his enlightening workshop on enhancing food safety and quality through modern processing techniques. His thorough and engaging presentation has provided us with a deeper understanding of how innovative processing techniques are crucial in ensuring both the safety and quality of food products. Mr. Sinha's expertise in the subject, combined with his practical insights into the latest trends and techniques, had broadened our knowledge of how modern methods can address the challenges faced by the food industry today. We are thankful for the time and effort Mr. Sharma sir dedicated to making this session so informative and impactful. His valuable contributions have not only enriched our understanding of food safety and quality, but also inspired us to explore and implement these advancements in our own practices. On behalf of everyone here, we offer our heartfelt thanks to Mr. Anish Sharma sir for an expression workshop. Thank you, sir.
Okay. Thank you. Okay.
Thank
So,
you, sir. Thank you so much. And, I will communicate for the proceedings. And we have some guest lecture requirement for our own students, sir. I think I will disturb you further. I have.
yeah. No
Yes.
problems.
Yeah.
Okay.
Thank you so much.
Thank you, sir.
Yeah.
So, I'll
Thank
be
you, sir.
leaving. Yeah.
Yes, sir. Yes, sir. Participants, thank you so much. And tomorrow session is 2 o'clock, not 6 o'clock. So we'll be having 3 sessions tomorrow. We'll be starting at 2 o'clock, and then 2 to 3:30, 3:30 to another session. That is 3:30 to 5 o'clock, and then 5 to 6:30. Then after 6:30, you'll be having a feedback session, and also you write online test. There will be a Google form will be to you, and you write the online test. Then you have to give the feedback in the Atal form, and finally valedictory will be there from 7:30 to 8 o'clock. So please join, and we'll finish the. Once you finish the online test and feedback, you'll be able to download the certificates. So please be in time. Thank you so much. Tomorrow we'll meet.
Thank you, sir.
Thank you, sir. Thank you, sir. Thank you, everyone. Thank you. I'll end the meeting now. Joel, you can end the meeting.
Okay, sir.